get started because we have only 16 weeks. So even today is the first week. Okay. I know some courses they just hand out the syllabus and go over the syllabus. That's it for the first lecture. But obviously, because of the shorter semester, I think we better start covering some material today. So the good thing about the beginning of this course is that most of the stuff here is pretty easy. Okay, as I said, you should have learned it in high school. Okay. I mean, of course, at that time, you learn this material in Chinese. So, you just need to translate what the jargon that you have learned in your high school, okay, into English. So, linear equation and variable is represented by this. Okay, where x1 to xn are variables, and x1 is what we call leading variable. Okay, and a1 to an are we call constant or coefficients for these variables. Okay, and where a1 is in particular is the leading coefficient. In here, when we say x1 is leading variable and a1 is the leading coefficient, in particular, a1 cannot be 0. Okay, if a1 is 0, then we will say x2 is the leading variable. So whichever that has a non-zero coefficient, okay, with the smallest index, is the leading variable. Okay? And the B is what we call constant term. Okay? So if you have S1 to Sn is real numbers, okay, for given linear equation, okay, assigning this S1 to Sn to S1 to Sn to x1 to xn, okay, this assignment is a solution if the equation, if this equation is satisfied. Okay. So, for some examples, okay, we have 6 linear equations here. Can somebody tell me which one or which ones are linear equations? Obviously, the first one, 2x minus 3y equal to 4, is a linear equation. The second one, unfortunately, is not, because we have xy term. Okay. The third one is not either, okay, because y and x appear in the denominator. The fourth one, okay, x squared plus y squared. Square term, okay, is not considered linear. Okay. How about fifth one? Fifth one, 2 sine x minus y equals 14. Okay. In here, x is used as in the sign. Okay. Because sine x, okay, is not considered linear. Okay, so this is not linear equation. However, the number 6, sine 2x minus y equals 4, this one is linear equation, even though sine 2 looks complicated, but the sine 2 nevertheless is a constant. Okay, sine 2 is a constant. Okay, it's a real number. Okay. So 1 and 6 are linear equation, and all the others are not. And for as a example of the solution, okay, even 2x1 plus x2 equal to 4, x1 equal to 1 and x2 equal to 2 will be one solution for this linear equation. Obviously, 1 for x1, 2 for x2. This equation obviously, linear equation obviously is satisfied. Okay, and you could go one step further. Okay, for any real number t, x1 equal to t and x2 equal to t minus 2t. Okay, is a solution. Okay, we call this one is one way to solve general solution. Okay, to represent general solutions for this linear equation, in which t is in particular parameter. Okay, it's called a parameter. It is a general solution. So you have learned this in high school, right? Nothing particular. It's just we just go over them very quickly. So assume u equal to u1, u2 up to un, and v equal to v1 to vn. Okay, we have two vectors. Okay, two solutions of x1, a1 x1 plus a2 x2 blah 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 plus an xn equal to v. We want to prove that for any real number c, u plus c times u minus v is a solution of a1 x1 plus a2 x2 plus blah blah plus an xn. How do we do it? So usually it's a pretty straightforward. You just try to use the recognition. Okay, you only show that is a solution. Okay, first you try to represent the u plus c u minus v. Okay, then it's going to be u1 plus c u1 minus v1, right? That u2 plus c u2 minus v2. So we have this un.你可以帮忙去拿一些这个签字笔，因为这个还要带纸。西藏黑暗。So we want to see this one is a solution. So we're talking. So it's going to be A1 times U1 plus C U1 minus V1 plus A2. Plus an A2 followed by A and U1, right? So we have A1 U1 cross A2 U2 cross A and U1. Okay, we get rid of this.
前面有。
We have the first and then, okay, we have the first one, and then we have like plus C U1 A1, C U2 A2, and so on. So we get rid of this. And then the last one, minus C A1 B1 plus A2 B2 plus A and B and so we can pretty much like write the above thing into three parts. And this one obviously is P, right? Because we know U is a solution of this linear equation. So obviously like A1 U1 plus A2 U2 plus blah 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 plus A U1 equal to B, right? Same thing goes this one, this way. This one, okay, because we know B is the solution for this linear equation. This one is B. So eventually what happens is that it becomes B plus C times B minus C times B. So it's going to right? So we know like this thing is U cross C times U minus B is indeed the solution of this linear equation. So what is important here? Okay, the implication of this proof is that when you are given, because like this C can be arbitrary, right? 这个 C 是一个任意的数字，对不对 ？Okay, so if you have two solutions for one linear equation, if you have two solutions for one linear equation, you can always use these two solutions to construct infinite number of solutions as long as you provide different values, right? 就说如果说从这边你就知道说，说给定你两个，说这个 solution， 这个linear equation 有两个 solution， 你可以用这两个 solution 兜出来无限多的这个 solution， 只要给不一样的 C 的值，对不对 ？OK。Obviously, to do that, U and B have to be equal. To do that, U and B have to be equal. If U and B are the same, this thing becomes zero. Then you have only one solution. So that's one linear equation. Okay. Now we are moving toward a system of linear equations. In particular, okay, we're going to have a system of n linear equations. And still we have n variables. So they can be written like this. So it's a11x1 plus a12x2 plus blah 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 plus a1nxn equals b1. So a21x1 plus a22x2 plus blah blah plus a2nxn equals b2 and so on. So we have an1x1 plus an2x2 plus blah 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 plus annxn equals bn. So in other words, we have x1 to xn n variables, and we have n, okay, so n rows of linear equations. Okay. So once we have a system of linear equation, then okay, when we have a solution, okay, that means that solution has to satisfy every inner linear equation in this system. Okay. And in high school, okay, or junior high, you have seen this thing, right? 就是你在学那个高中还是国中数学的时候，你有看到相关的，you are given two linear equations, okay, with two variables, and you try to represent this, each linear equation, geometrically as a line on two-dimensional, point system, right? And so this one, you can solve this system, okay, and come up with one solution. So it turned out to be this one, okay. And this one is another case. Okay, you have two, linear equations of two variables, and okay, these two equations obviously are, overlapped, completely overlapped. So in other words, okay, you have infinite number of solutions, right? Okay, the third one is like, okay, these two linear equations, unfortunately, they are in parallel, okay, on PC. Okay, and they have no intersection. Okay, in geometry, an intersection means the solution for this system, right? Okay, so this is two-dimensional case. Obviously, this thing can be, extended to n-dimensional, right? Can be extended to n-dimensional. You can imagine. So, the number of solutions of a system of linear equations must be one of the following cases. The first one, exactly one solution. Second one, infinite number of solutions. The third one, no solution. Only these three cases. So we need to prove that. How do we prove it? I mean, because we don't even know, like, the number of linear equations, and we don't know, like, the number of variables either. So it's impossible for us to draw the figure, okay, to discuss like the number of possible solutions, right? The one thing for sure we know about is that we can try to in your freshman year, learn discrete math, right? By the way, I happen to teach discrete math for almost 10 years, probably more than 10 years. Now, because I 2 years ago, I became a common chair, so I have to, the EMI, there's a KPI called EMI, so, 就是有一些课必须要英文教了，那这个特别强调说是这个英文教课必须要是大二，那你知道那个 discrete math 因为是大一的课，所以我只能因为当系主任必须要 fulfill 这个 KPI， 所以我就跳到大二来教这个线性代数英文教。其实我大一的时候线性代数理论数学我也想英文教，但是我曾经尝试过英文教，但是那个是在那个 EMI 这个事情之前。Two things I want to mention, okay, before I continue. Okay. First thing, okay, to be honest, okay, I teach this course in English. It's not primarily because of the EMI KPI. Because as I said, I can teach any courses in English. I don't have to teach, this course in particular. Teaching this course, like the second year course in English, yes, is to fulfill the KPI. But to be honest, I teach almost every course in English. Okay, so you may ask, why do I teach courses in English? 你觉得说奇怪为什么是你要用英文教课？英文教课不是要比较麻烦吗 ？Okay, because I have, since I went to US to study like graduate like program, like I stayed in the US for 15 years. Okay, so I before I moved to US, okay, my major was mathematics. Okay, so all the computer science knowledge I learned in English. So to be honest, it's easier for me to teach computer science courses in English than in Chinese. Okay, that's the first reason. The second reason is, I really want to have some opportunity to practice my English. So teaching courses in English is for my own sake. It's not because of me. Okay, 我希望有一些课程，有一些机会可以多讲一点。OK， 所以这个是也是我自己希望的事情。OK， so this is the first thing. The second thing I forgot to mention is that, okay, so today, okay, I just gave out like I think like more than 10 like passcode 密码，我再给了大概10张。Okay, so obviously we have at least like more than 10 students. They are absent. 他们至少10个学生接没来。OK， 因为理论上50个人，应该这个课长应该是做不来，所以有另外一个10个学生可以进来做，代表说至少10个学生以上教课。Not to worry. Okay. Okay. I do not take attendance. Okay. 我的 philosophy 是我不点名。Okay. 如果你要教课 ，go ahead, be my guest. Okay. I think like I try my best to teach this course well. Okay. I hope like if you come to the class, you can learn something. But if you think you can study this course material and get better, like get learn faster, be my guest, no problem. It's okay. Okay. I mean, 你知道，像我自己拿 take myself as example. Okay. 我自己在大学的时候，因为我眼睛在高中的时候就坏掉，所以在大学的时候，其实我是没有办法上课，然后边听课边做笔记，没办法。那可是我们在台湾数学系的时候，因为我们的数学系的老师都非常的，非常的 他们上课就是只上给那些资优生听的，我们一般的学生是听不懂他们在上什么。所以我在从大学以后，我基本上所有的课我都自己念，不是被逼的，不是我要讲，是因为上课老师基本上我不会不管你们 ，OK， 但是我在大学的时候，我老师不管，OK， 他们就是上面，就只有在我们台大学习就只有一个老师，在我那个年代就只有一个老师，真的有关心一般生，其他的老师全部都在上课给资优生，所以我不上课基本上都得要回去自己，所以我们习惯了。那这个习惯其实有点好处，因为我刚到美国的时候，其实我上课，毕竟我刚到美国嘛，老美英文讲得比较快，其实很难听的。那我后来就考自己，那我后来英文也比较好一点，就是让你们知道说，其实我也encourage你们自己 study。OK， 如果你们自己 study 的学习速度可以比我上课听课来的快，那其实也是很好的事情。但是如果你们自己 study 有问题，你们可能需要自己解决，那就你们自己需要去负责。然后这第一点，然后第二点是我的 quiz， 就像我那时候讲的，如果你有特别的 excuse 缺课，没有考试，不管是 quiz 或者 midterm final， 那是你自己的事情。就是说你要知道说什么时候考 midterm， 什么时候考 final， 什么时候考 quiz。你们至少你要翘课没有关系，那时候不然就是加分，好吧？这应该 fair game， 对不对？很公平，好吧？所以我可以期待下堂课可能就我们这个教学课，不过没关系，就像我讲的说，其实你们来，我希望可以帮助你。如果你们觉得说我上课可以帮到你，那你们自己带自己练，这不是问题。Okay, so okay, come back to this course. Okay, I just mentioned about discrete math. Why do I need to talk about discrete math? Because discrete math, in discrete math, you should have learned logic, right? 你学到逻辑，对不对？所以 in logic you have like a concept of sets, right? 基本，对不对？Let me ask you this question. Okay. How many cases, possible cases for the number of solutions? The first one, no solution, right? This obviously is one set, right? The second set is one solution. The third set is two solutions. The fourth set is three solutions, and so on. And the other is infinite solutions, right? But remember, in the previous slide, here, I just told you, if we had two solutions, then we can construct an infinite number of solutions for one linear equation, right? Right? 我们是不是在讲过这个？如果说我们有两个 solution， 你就可以